Today we're going to talk about rationalizing radicals and complex numbers. We did some rationalizing last week, but when we had a radical or an I in the denominator, it was just a single radical or a single I. Today we have radicals that are part of a binomial, or we have imaginary numbers that are also part of a binomial. So what this means, a binomial is two terms. So since we know we cannot have a radical in the denominator, we have to get rid of it. If that radical is part of a binomial, we have to use a binomial to get rid of it. We're going to use something called a conjugate. First, I'm going to put parentheses around the current binomial in the denominator. To multiply by a conjugate, I'm going to use all the same exact numbers, and the only thing that is going to change is the sign in the middle. So I will write down 4 square root of 5 plus 6 square root of 2. Now, just like last week, whatever we multiply the denominator by, we're going to multiply the numerator by exactly the same thing. In this problem, there's only one number in the numerator. So I'm going to take this one number and distribute it to both of the terms inside the parentheses. When I do that, you do need to remember that since 2 is an outside number, it's not underneath a radical, it can only multiply times the outside numbers in each of these terms. So my answer is 8 square root of 5 plus 12 square root of 2. Now I'm going to multiply the two parentheses in the denominator. Remember, when we do a binomial times a binomial, we use a process called FOIL. It is a double distribution, and I'm going to go through this entire process on this first example, but I'm going to show you a shortcut on problems 2, 3, and 4. First, we're going to take the first term in the first parentheses, and we will distribute that term to both of the terms in the second parentheses. When I do that, again, be very careful to only do outside numbers times outside numbers and inside times inside. I'm going to get 16 square root of 25 plus 24 square root of 10. Now that I have distributed the first term, I'm going to go back and I'll take the second term, negative 6 square root of 2, and I'm going to do that same thing, distribute it to both terms in the second parentheses. That will give me negative 24 square root of 10 and negative 36 square root of 4. Let me erase that real quick. Now it's time to clean up things and simplify what we can. I do want to point out these two middle terms, they're exact opposites, meaning a positive 24 and a negative 24, and I can cancel them out. That is going to be true every time you multiply conjugates. So we do actually shortcut the process, and instead of doing a full double distribution, we only multiply the first terms and the last terms because we know those two middle answers are going to always cancel each other out. In the numerator, both of these radicals are in simplest form and they are not like radicals, so I cannot combine them. That gives me 8 square root of 5 plus 12 square root of 2. In the denominator, I do have a couple perfect squares that I need to go ahead and solve. The square root of 25 is 5. When I solve this, it's going to multiply with the number that is in front of it. 16 times 5 is 80. Over here, the square root of 4 is 2. It will also multiply with the number in front of it. A negative 36 times 2 is negative 72. I can combine the two terms in the denominator. 80 minus 72 gives me 8. Now I'm not done yet. You are allowed to reduce outside numbers if they all three have something in common. In this case, all three of these are divisible by 4. If I divide 4 into 8, I will get 2. 4 into 12 is 3, and 4 into 8 is 2. So my final answer is 2 squared of 5 plus 3 squared of 2 over 2. In number 2, we're going to use the same exact process. The only difference is both the numerator and the denominator have binomials. Since the denominator has a radical, and I cannot have a radical in the denominator, I have to get rid of it. Since it's part of a binomial, I have to use a binomial to get rid of it, and so I will use its conjugate. It will be the same exact numbers. The only thing that will change is the sign in the middle. Whatever I multiply the denominator by, I'm going to multiply the numerator by exactly the same thing. That's how I keep this problem balanced. On top, I will have to use double distribution. There can't be a shortcut because these are not conjugates. But in the denominator, since these are conjugates, I will only multiply the first terms and the last terms. So on top, I'm going to start by taking my first term, negative 5, and distributing it to both terms in the second parentheses. That gives me negative 25 minus 5 squared root of 2. Now I'll go back, take the second term, distribute it times both terms in the second parentheses. That gives me positive 5 square root of 5 and positive square root of 10. In the denominator, like I said before, since these are conjugates, I only have to multiply the first terms, 5 times 5, which is 25, and the last terms of each parentheses. Negative square root of 2 times positive square root of 2 is negative square root of 4. Now it's time to clean up the problem and see if any of my terms can combine. In the numerator, every single one of these terms is already written in simplest form. Even square root of 10, if I break down 10, it's 2 times 5. So I don't have any numbers that show up twice that could come out of my radical. I cannot do any combining of these terms because they're not alike. In the denominator, I can solve the square root of 4 and I get 2. 25 minus 2 gives me 23 in the denominator. So just to rewrite this and clean it up, the numerator is negative 25, negative 5 square root of 2, positive 5 square root of 5, and positive square root of 10. The denominator is 23. The only way that I can simplify any of these terms is if the outside numbers, every single one of them, had something in common. They don't, and so this is my final answer. Numbers 3 and 4, we're going to use the same process again, but this time instead of radicals, we have I. Just like before, we have an I in the denominator, and we have to get rid of it. This I is part of a binomial, so we have to use a binomial to get rid of it. We will use the conjugate, same exact numbers with the opposite sign in the middle. Whatever we multiply the denominator by, we're going to multiply the numerator by exactly the same thing. Since my numerator is a single term, I will only take this single term and distribute it to each term in the second parentheses. So on the top, I have 30i minus 12i squared. In the denominator, I do have a binomial times a binomial, but since they are conjugates, I only have to multiply the first terms and the last terms because I know the other terms would cancel out if I wrote them all out. When I multiply the first terms, 5 times 5, I get 25. And when I multiply the last terms, positive 2i times negative 2i, I get negative 4i squared. Now it's time to clean things up. Last week I taught you that the value of I squared is negative 1. And so anytime you see I squared in a problem, you need to make that replacement. If I rewrite things, make sure that you use parentheses around your negative 1, because you can see here that negative 12 was multiplied times I squared. So negative 12 will need to multiply times negative 1. Now, when I multiply negative 12 times negative 1, I get positive 12. Same thing down here. When I multiply negative 4 times negative 1, I get positive 4. In the numerator, I cannot combine these terms because one of them has an I and the other one doesn't. So I will just write it with the real number first, 12, plus 30i. In the denominator, I can combine these two terms. 25 plus 4 is 29. Now, just like before, if all of your outside numbers have something in common, you are allowed to reduce them, but it's all or nothing. And in this case, 12, 30, and 29 are not divisible by the same thing, and so I'm done. Number 4. This is an example of an imaginary complex problem where we have a binomial in the numerator and a binomial in the denominator. Again, we have this I we need to get rid of. Since it's part of a binomial, I'm going to use a binomial to get rid of it. I will use its conjugate. Now, just to remind you, the only thing that changes on a conjugate is the sign in the middle. So I will write down negative 1 plus 6i. Whatever I multiply the denominator by, I'm going to multiply the numerator by the same exact thing. On top, I will have to use all 4 steps of FOIL. I will do a full double distribution. But in the denominator, I will shortcut since these are conjugates and I will only multiply the first and the last. So on top, let's take the negative 2 and distribute it to both terms in the second parentheses. That's going to give me 2 minus 12i. Now I'll take positive I and distribute it to both terms in the second parentheses. That gives me negative I plus 6i squared. In the denominator, we only are going to multiply the first terms. Negative 1 times negative 1 is positive 1. And the last terms, negative 6i times positive 6i is negative 36i squared. We're going to make our substitution. Everywhere that I see an I squared, I'm going to replace it with its value, negative 1. Now remember, it's multiplying times the number in front of it, so that just essentially changes the sign of this number. A positive 6 times a negative 1 becomes a negative 6. Down here, negative 36 times negative 1 is going to become positive 36. Now I can clean things up and combine like terms. In the numerator, I'm going to combine my real numbers first. A positive 2 with a negative 6 is negative 4. Negative 12i and negative I is negative 13i. In the denominator, I have 1 plus 36, which is 37. Since 4, 13, and 37 do not have anything in common, I cannot reduce them, and therefore I'm done.